Chapter 11 is about polynomials, and the first two sections deal with vocabulary and just the basics of polynomials. So if we take a look at our first polynomial, there's our example 5x to the 7th plus da 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 da. Okay, a polynomial means there are multiple terms and they are all being added or subtracted. Okay, so all of these are going to be a plus or a minus sign. You're never going to see multiplication or division. Okay, notice they're also written in decreasing order. So the 7, 6, 3, da da da, decreasing order is called standard form. So this one is in standard form as we look at it right now. Some of the vocabulary here, leading coefficient. The leading coefficient when written in standard form is going to be your first coefficient. So the leading coefficient of this example is a 5. And the degree is the largest exponent that you see, which will then be the first one when it's written in standard form. So our largest exponent is 7. So far we have a leading coefficient, and I'm going to make that LC. So leading coefficient of 5 and a degree of 7. So that's what we got so far. And then there's some special names for the first 4 of those. So if the degree was a 1, I would call it linear. If it was a degree 2, I'd call it quadratic. Degree 3 is cubic, and 4 is quartic. Okay, the number of terms, we have here is 1, 2, 3, 4, 5. So this would be classified as a polynomial. Anything over 4, so 4 or more, is called a polynomial. Okay, if it was 1, mono for 1, 2, bi, 3, tri, and 4, poly. Okay, so depending on how many terms you have, that defines what it is. So this has a leading coefficient of a degree 7, and it is a polynomial. So when I ask you to classify things in terms of polynomials, you're going to have to tell me coefficient, degree, and how many terms it has. And if it has a special name, use that. So let's try a few of these. Example A, part A, has x squared plus 12xy plus y to the 4th. This is clearly not written in standard form, okay, but I can still classify it. So I see the largest exponent is a 4, so that makes it quartic. I see that I have 1, 2, 3 terms, so that makes a trinomial. And then I can tell me that the leading coefficient comes from the term with the largest exponent. So right here is a 1, so our leading coefficient is a 1. Okay, so quartic trinomial, leading coefficient of 1. Part B here, largest exponent I see is an 8. Okay, we don't have anything special for that, so I'm just going to call this an 8th degree. Next, I want to know how many terms I have. I have 2 things to underline, so that is a binomial. And then the leading coefficient is the coefficient on the one with the largest exponent. Okay, make sure you watch the negative. This is a negative 13 for our leading coefficient. And part C, okay, the largest exponent you see is a 2. However, this is just one term, and there's a 1 on the A, which means I'm going to add the 2. So this is actually a cubic function because our degree is 3. Okay, so I need 2 variables together on the same term, you add them to find out the degree. So this is a cubic, there's only one thing, so it's a monomial. And then obviously we don't have any other choice, but our leading coefficient would be 384. Okay, we can also come up with our own, so a quadratic polynomial. Okay, quadratic refers to the degree, and that would be a degree of 4. I'm sorry, 2, 2, 2. Quartic is 4, common mistake. So x squared. Polynomial means I have 4 or more terms. So I could say x squared plus x plus y plus 1. So now I have 4 things. X squared is 1, x, y, 1. Okay, so polynomial meant I needed 4 or more. Anything would work there with 4 terms with a degree of 2 being your largest. Okay, so that's the vocabulary. That's section 1. Section 2 is expanding, and we have already done this, so it's kind of a nice day to review. Just remember when I look at example C and the squares on the outside, that really means there's 2 of these brackets, which really means I have to, oh, that's right, FOIL. Okay, so when I FOIL, first terms give me 9x to the 4th. Outside terms give me 12x squared. Insides give me another 12x squared. And last give me a 16. So when I put that all together, I've got 9x to the 4th plus 24x squared plus 16. Now that I have it expanded, I could classify it here because it also wants me to classify it since we're working on vocabulary. So the largest exponent I see is a 4, which makes this quartic. I see 3 different terms, 1, 2, 3. That makes this a trinomial. And then the quartic part is the 4, and the coefficient there is the 9. So our leading coefficient here is a 9. Okay, part D is not something we've necessarily seen before, but it should make sense. FOIL means you have to take everything in the first set of parentheses, multiply it by everything in the second. So part D means I have to take everything in the first. So I'll start with my 5x squared and multiply it by both things in the second set of parentheses. So 5x squared times x is 5x to the third. 5x squared times 7, well, negative 7 would be negative 35x squared. So you take care of the 5x squared. Then I'm going to move on to the negative 4x and distribute that to both of those. So negative 4x times x is negative 4x squared. Negative 4x times negative 7 is a plus of 28x. Now that I've done the negative 4 to both of those, now I'm going to move on to the 3. And the 3 needs to go to both of those. So plus 3x minus 21. So basically this is just a longer FOIL. Okay, then you have to put your like terms all together. So I only have one that's a 5x to the third. Then I'll go ahead and say, okay, I have an x squared. Here's another one. Negative 35 plus negative 4 is a negative 39x squared. Then I'll look for my x's. I have a 28x and a 3x, so those are like terms. So those go together as 31x. And then at the end, I just have my minus 21 for my final answer. Okay, do make sure you are giving them to me in standard form like I have written it here. Okay, to classify this one then, largest exponent I see is a 3, so that makes that cubic. The number of terms I have is 1, 2, 3, 4, making that a polynomial. And then I want to know my leading coefficient, which would be the coefficient on the one with the largest exponent. So my leading coefficient is 5. Excellent. Hope things are going well so far. Now we'll just do one visual. It wants me to find the area of the object. Okay, so here's kind of two ways to look at it. I can kind of do it old school. So the area of this first triangle, or I'm sorry, the first rectangle would be 4x squared times x, which would be 4x to the third. If I move over to the one right next to it, 4x squared times 1 is 4x squared. Moving down to my negative 2x times x is negative 2x squared. Negative 2x times 1 is negative 2x. Moving along to the 3, then I'll have 3x and 3. So to put together the area, I would just have to add those all. So I've got 4x to the third. Next, I would say, okay, here's an x squared and here's an x squared. So I have 2x squareds together. Then I would put my x's together. So that would be 3x minus 2x is a positive x, and then plus a 3 at the end. Okay, so that's a visual way to do it, which is pretty nice. If you're not a visual person, you rather just do the algebra, okay? If I were to write the length of this top side up here to get the width of the top, that would be an x plus 1. And then if I wanted to, I could take the width of this side over here, which would be 4x squared minus 2x plus 3. And basically what you did is just turn it into an algebra problem like the one we did before. And if you were to FOIL that out, it would look exactly like this. So either one that makes sense to you is great. And one story problem, a compound interest run. Woohoo! Starting with the summer after his senior year, in high school, Jose worked to save money for medical school. At the end of the summer, he put his money into a savings account with an annual yield of 6%. Jose is planning on attending med school in the fall following his 4th year. How much money will be in his account? Okay, well, this seems kind of weird because we just did this. Okay, what's different is all of the amounts Jose's putting in are different. Okay, so I know I'm going to put $1,500 in the bank and I'm going to have some sort of interest. So I'm just going to leave that blank for right now. Then I'm going to have the $2,200 in the bank earning some interest for a while. Then I'll have the $2,100 in the bank for a while. Then the $3,000 in the bank for a while. Then the $3,300 in the bank for a while. Okay, so maybe I'll just put in A equals over here for our total amount. The next part I'm going to notice is that it's an annual yield of 6%. Well, this is what we did last chapter. You would turn that to be 1.06. divide that by 100 and add 1. So all of these would be 1.06. In all of these parentheses, we'd have 1.06 for our interest rate. Now the question is the amount here of interest the same for 3,300 as it is for 1,500? Well, absolutely not, okay, because the 3,300 came in last and the 1,500 has been there for 4 years, okay? So now we have to kind of think about how much interest he earns. Well, if he's taking it out following his 4th year, okay, the 3,300 isn't going to get any interest at all, actually, okay? So we'll get rid of that one, meaning the 3,000 got interest for 1 year, and then the 21 got it for 2, 3, and then the 1,500 got it for 4 years. So sometimes it's hard to know which way to start and where your exponent should be. So that's why I work myself backwards. Okay, start at the end like I did here, and then going backwards, you just increase it by 1. Okay, so there's a nice story problem, and hopefully today is a good day. But if it's not, go ahead and write some questions, think about it real hard, and bring those to class tomorrow.